Plugmold strips on lab benches usually require hard wiring, even if the benches aren't bolted in place. This requirement is rooted in electrical safety standards and built-in codes designed to prevent hazards and ensure the safe operation of electrical equipment. Firstly, consider the National Electrical Code, or NEC, which provides comprehensive guidelines for electrical installations. The NEC aims to protect people and property from electrical hazards. It's not just about preventing shocks, but also about minimizing the risk of fires caused by faulty wiring or overloaded circuits. Secondly, think about the potential for movement. Although the benches might not be bolted down, they could still be moved or shifted. If the Plugmold strip is simply plugged into a wall outlet, movement could strain the cord, potentially damaging it and creating a safety hazard. A hardwired connection, on the other hand, provides a more secure and reliable electrical pathway. Thirdly, the type of equipment being used on the lab benches also plays a significant role. Laboratory equipment often draws a substantial amount of power, and some devices are highly sensitive to voltage fluctuations. A hardwired connection ensures a stable and consistent power supply, which is essential for the proper functioning of sensitive equipment and prevents damage. Fourthly, ground fault protection is another critical aspect of electrical safety in laboratories. Ground fault circuit interrupters, or GFCIs, are designed to quickly disconnect power when a ground fault is detected, preventing electrical shock. In many jurisdictions, electrical codes require GFCI protection for outlets serving lab benches, particularly those near water sources or other potential hazards. Hardwiring the Plugmold strip allows for the easy integration of GFCI protection into the circuit. Fifthly, consider the overall electrical load on the circuit. If multiple pieces of equipment are plugged into the Plugmold strip, the circuit could easily become overloaded. Overloading a circuit can cause the circuit breaker to trip, interrupting power to the equipment and potentially damaging it. A hardwired connection allows for the use of a dedicated circuit with an appropriate ampacity to handle the load. Sixthly, the specific requirements for hardwiring Plugmold strips can vary depending on local built-in codes and regulations. It is crucial to consult with a qualified electrician or electrical inspector to determine the specific requirements in the jurisdiction. They can assess the electrical load, the type of equipment being used, and the potential hazards in the laboratory environment. Seventhly, the use of flexible metal conduit, or FMC, is often recommended when hardwiring Plugmold strips to lab benches. FMC provides a protective pathway for the electrical conductors, shielding them from physical damage. It also allows for some degree of flexibility, which can be useful if the benches need to be moved or reconfigured. Eighthly, the wiring must be properly sized and installed according to the NEC. The size of the wire depends on the ampacity of the circuit and the length of the run. Improperly sized wiring can overheat and cause a fire. The wiring must also be properly terminated and connected to the circuit breaker or fuse. Ninthly, the connections must be made in approved junction boxes. Junction boxes provide a safe and secure enclosure for electrical connections, protecting them from moisture, dust, and physical damage. They also make it easier to access the connections for maintenance and repairs. Tenthly, all electrical work must be performed by a qualified electrician. Electrical work is inherently dangerous, and it should only be performed by someone who is properly trained and licensed. A qualified electrician has the knowledge and experience to install electrical wiring safely and correctly. Moreover, regular inspections of the electrical system are essential to identify and correct any potential problems before they become hazards. These inspections should be performed by a qualified electrician. The electrician will check the wiring, connections, and grounding system to ensure that they are in good condition and meet all applicable codes and regulations. Furthermore, the use of surge protectors is recommended to protect sensitive electronic equipment from voltage spikes. Voltage spikes can damage electronic components and cause equipment malfunction. Surge protectors divert excess voltage away from the equipment, protecting it from damage. Consider the layout of the laboratory and the placement of the lab benches. The location of the Plugmold strips should be carefully planned to ensure that they are easily accessible and do not create a tripping hazard. The strip should also be located away from water sources and other potential hazards. Also, the type of receptacles used in the Plugmold strip should be appropriate for the equipment being used. For example, some equipment requires special receptacles with ground fault protection or surge suppression. The receptacles should be clearly labeled to indicate their voltage and ampacity. Additionally, training is vital for laboratory personnel on the proper use of electrical equipment and the hazards associated with electricity. This training should include information on how to identify and report electrical hazards, how to use electrical equipment safely, and how to respond to electrical emergencies. Remember that the primary reason for hardwiring Plugmold strips, even on non-bolted benches, is safety. It's about protecting the people who work in the lab and the equipment they use. Ignoring these safety measures can lead to serious consequences, including electrical shock, fire, and equipment damage. Safety is paramount. The specific regulations might depend on the state, city, and even the type of laboratory. Some facilities, such as those handling hazardous materials, might have even stricter requirements. Always verify with the local authorities and an experienced electrician. Proper grounding is crucial in a laboratory setting. Grounding provides a path for stray electrical current to flow safely back to the source, preventing electrical shock. The grounding system must be properly installed and maintained to ensure its effectiveness. Ensure that all equipment is properly grounded and that the grounding system is regularly inspected. The use of extension cords should be avoided whenever possible. Extension cords are often a source of electrical hazards, such as tripping hazards and overloaded circuits. If an extension cord is necessary, it should be heavy-duty and properly sized for the load. The cord should also be inspected regularly for damage. Proper labeling of electrical panels and circuits is essential for safety and maintenance. Each circuit breaker should be clearly labeled to indicate the equipment it serves. This makes it easier to identify the correct breaker to turn off in case of an emergency or for maintenance purposes. Another consideration is the presence of flammable materials in the laboratory. If flammable materials are present, special precautions must be taken to prevent ignition. This may include the use of explosion-proof electrical equipment and the implementation of strict procedures for handling flammable materials. Furthermore, consider the ergonomic aspects of the lab bench design. The Plugmold strip should be located in a position that is easily accessible to the user without requiring them to reach or strain. This can help to prevent injuries and improve productivity. It is also important to ensure that the Plugmold strip is securely mounted to the lab bench. If the strip is not properly secured, it could be accidentally dislodged, creating a safety hazard. The mounting hardware should be appropriate for the type of lab bench and the weight of the Plugmold strip. Also, the selection of the Plugmold strip itself is important. The strip should be made of durable materials and designed for heavy-duty use. It should also have an appropriate number of receptacles for the equipment being used. It is also a good idea to choose a Plugmold strip with built-in surge protection. In addition to the technical aspects of hardwiring Plugmold strips, it is also important to consider the human factors. Laboratory personnel should be trained on the proper use of electrical equipment and the hazards associated with electricity. They should also be encouraged to report any electrical hazards or concerns to their supervisor. A safety-conscious culture is essential for preventing electrical accidents in the laboratory. This culture should be fostered through regular training, clear communication, and a commitment to safety by all members of the laboratory team. The best practice is to consult with a qualified electrical engineer who can assess the specific needs of the laboratory and design an electrical system that meets all applicable codes and regulations. The electrical engineer can also provide guidance on the selection of appropriate equipment and materials. Remember that electrical safety is an ongoing process. It is not enough to simply install the electrical system correctly. It is also important to maintain the system properly and to be vigilant for any potential hazards. By following these guidelines, you can help to ensure a safe and productive laboratory environment. Moreover, the NEC is updated every 3 years. Staying current with the latest edition of the NEC is important to ensure that the electrical system meets the latest safety standards. The NEC is available for purchase from the National Fire Protection Association, or NFPA. NFPA also offers training and certification programs for electricians and other electrical professionals. The NEC isn't just a set of rules, but a constantly evolving set of best practices, and compliance ensures that a facility is operating at the highest safety level. It is recommended to consult with a qualified professional to interpret and apply the NEC to specific situations. Moreover, consider the long-term needs of the laboratory. As the laboratory evolves, the electrical system may need to be upgraded or modified to accommodate new equipment or procedures. It is important to plan for these future needs when designing the electrical system. This may involve installing additional conduit or raceways, or providing spare capacity in the electrical panels. Ultimately, the goal is to create a flexible and adaptable electrical system that can meet the changing needs of the laboratory. Finally, when choosing an electrician or electrical contractor, it is important to verify their qualifications and experience. Ask for references and check their license status with the local licensing board. A qualified electrician will be able to provide you with a certificate of compliance upon completion of the work. This certificate will verify that the work was performed in accordance with all applicable codes and regulations. Prioritizing safety and engaging qualified professionals ensures a safe and productive laboratory environment for everyone.